Polygons is a closed shape with the same number of sides and angles. That's basically what a polygon is. So just so you know, all the shapes that we've studied so far, triangles, that's a closed shape, many sides, many angles. 3 angles, 3 sides, right? Then you've looked at rectangles, and it keeps going. So once we go past 4, we start just saying polygons in general. Some of them have specific names, but that's one thing I want you to remember. There's convex and concave. Concave, you have the sides are caving into the shape, and you'll have an angle right here that's called a reflex angle. It's bigger than 180. To be honest, I don't think you're going to have to worry about that in this unit, but I want you to at least know about them, okay? Convex is what we're going to be all about, okay? Then, another category that I'm going to always test you on, or always seeing if you know what that means, there's regular versus irregular polygons. And I will focus on regular, because if you know what a regular means, you will know what irregular is. So for something to be regular, give me 1 second here, I got my notes. You need 2 things to be true. All sides are congruent, and all angles are congruent. That's what you need for something to be called normal. Okay? So remember that. Have that on your study sheet if you must. So, right? Equilateral triangle. So if you have an equilateral, all 3 angles are the same. All 3 sides measure the same. By the way, what are all angles going to measure? 60, always. Equilateral, 60, right? You split 180 equally amongst the 3. And so a square, of course, you have 90s in every corner, every angle, and all 4 sides are the same. Okay, we got that. Therefore, anything that doesn't meet the criteria is in the irregular camp. So for example, an isosceles triangle. You're like, wait a minute, it's got 2 sides that are the same. Yeah, but that's it, only 2. You need all sides to be the same, okay? A rectangle, Mr. Dirksen, a rectangle has 90s on all 4 angles, right? So it meets this criteria, but does it meet the criteria where all sides are the same? It doesn't. So all of these are irregular. That's what I want you to remember. If you know what regular polygons are, you will know what irregulars would be, because if it doesn't meet that, it's in the other camp. Okay, next. This is a bit of a review here. Properties. All polygons have interior and exterior angles. Interior and exterior angles are always supplementary. They add up to 180 degrees. And here's where you have, I'm going to use a red pen and a blue pen, but you can do whatever works for you. I'm going to first identify the interior angles. So there's 1 here, 1 there, 1 there, 1 there. So these are called interior angles. And then there are how many sides do we have here? 5 sides, right? How many interior angles? 5 interior angles. And how many exterior do you think you're going to have? 5. You're going to have 5 as well. So just be careful how you draw your exterior angles here, folks. You go to any corner you would like. I'm going to focus on this one here. And pick one of the sides. I'm going to pick this one. So you kind of travel along it, and then when you get to the corner, you keep going. You extend it. And the angle that's formed between the side and the line you extended is called the exterior angle. Can you see that they're supplementary? Can you see that they're going to add up to 180? Right? Yeah, it's visible. So next one, I'm going to travel here. And when I get to the corner, I do this. That's exterior right there. And travel this side. That's exterior right there. exterior, exterior. So there are 5 exterior angles. I'm writing that down up here as well, that there are 5 sides, 5 interior angles, 5 exterior angles. And I will make a note that the exterior plus the interior are always going to add up to 180. Which means, just like before, what did you do if you knew one of the 2 angles? What would you do to find the other one? You would subtract it from 180, right? So if I give you the interior, you can easily find the exterior and vice versa. So I will just show you what I do if I use this formula to figure out my interior angle or the exterior angle. Right? 2 formulas are can be created as a result of that initial property. Next, the sum of exterior angles is always 360. It's worth highlighting. Regardless of irregular or regular, regardless of the number of sides. So if you were to add up these 5 exterior angles here, it would be 360. Watch this. What if I had a polygon with 100 sides? It would have 100 exterior angles. If you added up all 100 exterior angles, it would always add up to 360 still. It doesn't matter what you do. The exterior angle sum is always 360. Okay? So remember that. Next page. Here are the formulas that I want you to have. And for this particular unit, guys, if you see the letter N, N stands for the number of sides, okay? So that's important. All of these formulas, it's a little weird, the notation, but don't worry so much about the N here. That just tells us how many sides that polygon has that we're solving for, okay? So when for example, if I have a 6-sided, I will find S of 6, and I'll find what that is. What does S stand for? S stands for the sum of interior angles. I would have the formula, and I would have what it does as well, unless you think you're going to remember that. I, this is capital I, by the way, in case you're wondering, it's not L. Okay, that's all my computer could do there. It's n minus 2, so sides, number of sides minus 2 times 180 divided by the number of sides. Okay, so that is the measure of each interior angle. Watch the next two, they're identical. Look at the formulas, they're identical. C stands for the measure of a central angle. E stands for the measure of each exterior angle. And D stands for the number of diagonals that you can draw inside a polygon. More about that in a bit, okay? And here's another color coming up, okay? I don't know if you notice ICE. I-C-E. Those formulas will only work if you have a regular polygon. It goes by the assumption that all sides measure the same and all angles measure the same. So think of ICE. Soon we'll think of that, unfortunately, too often. Okay, but that's something to remember. All right, let's use them. Let's I won't always ask for all of them, by the way, but let's see what we can do here. It says label ice. Let's do that one here. Label ice, so label an interior angle, a central angle, and an exterior angle. Then calculate, are you psyched about it? I tried something, I don't know. For the following regular polygons. I know that's not how you spell psyched, but there you go. So one interior angle, you pick any corner and just do one of these and put a capital I there. Okay, so that would be the measure of one interior angle. C, watch this one. C stands for central. So you got to go to the center, make a dot, and then you're gonna cut out a slice of pizza, right? So you're gonna go to one corner, and then you travel along that same side, and once you get to the other corner, you slice back to the center. And this angle right here is what we call central. That's one central angle. Question, how many interior angles does this have? 5. How many central angles will it have? 5. Yeah. And exterior angle, let's do it right next to the interior. I kind of don't mind having that. So this would be an exterior angle right there. So if I ask you to label 1, just label 1, okay? So there would be 5 of each, but here we have them labeled. So let's do the formulas. I will start with S here. So number of sides, this thing has 5 sides. Can you please look up? I'll just beg you to count this way, because once we have more than students miscount, you put a check mark where you start counting 1, 2, 3, 4, 5. That way you won't double count where you started, okay? So 5 sides. I have a software I can do 15 sides, 16, 17, I can do whatever, okay? So we know that n is 5 here. So the sum of all of the interior angles, right, this is just, you put 5 in there, is n minus 2 times 180 degrees. And you can just go S, to be honest. It'll be 5 minus 2 times 180. S is 3 times 180. And that is 540 degrees. So the more sides it has, the bigger S is going to be, okay? Because the angles get bigger and bigger as you have more sides, right? It almost, they keep increasing. So it's usually a bigger number for S. Next, let's find the measure of one interior angle. One interior angle calls for n minus 2 times 180 over n. And now it's 5, right? So 5 minus 2 times 180 over 5. So it's 3 times 180 over 5. Did we do the top already before? 3 times 180? We figured it out already. It's 540. So it's essentially 540 divided by 5. Okay, you're splitting the 540 equally amongst 5 angles. So I is 108. Sometimes it's a decimal. Sometimes it's a whole number. A central angle. Central angle calls for 360 divided by n. So we'll go 360 divided by 5. That would be 72 degrees. One of these central angles measures 72 degrees. Next. Yeah. How? This is the formula. So I give it to you here. Central angle is 360 divided by number of sides. Okay, E, let's do this before we go. E is exactly the same, guys. But I want you to notice something. What should E and I always add up to? You see that they add up to 180? Could I have used 180 minus 108 to figure out the exterior? Yes. So your homework, I told you already what the homework is going to be, right? Just add these to your formula sheet. Okay, thank you guys. Saved by the bell.